Alright, let's look at these two circuit examples. We're going to use the loop rule to solve them. And I'm going to start this one out at this point A. And usually, now it doesn't matter where you start out on a loop rule. You can start out anywhere. You can start at this corner, that corner. You just have to follow the rules for analyzing the circuit. Now, the next thing I do, I look at the EMFs, the batteries, the voltage sources. Positive direction here, negative here, positive here, negative here. That's 18 volts, that's 6 volts. Now this EMF is sending a current in this direction. This EMF is sending a current in this direction. Now, they run into each other. If you have 18 volts going this way and 6 volts going this way, you have an overall current going around the circuit that way, and it's going to be the difference between the two batteries, which is 18 minus 6, so 12 volts. Now, we're going to start at point A, and we're going to go around the circuit and derive the equation. Starting from here, we're going to cross the EMF in the direction of the current produced by the EMF, so that's going to be a positive E2. The first loop rule, if you cross a voltage source in the direction of the current produced by the voltage source, it's going to be a positive EMF. Crossing the first resistor in the direction of the conventional current, that's going to be negative IR1. So minus IR1. Now, we only have one current overall, the net current, so we just have to call it I. We don't have to call it I1 or I2. That's just I. Crossing the second resistor, that's going to be minus IR2. And then crossing the E, this is negative because you're going against the direction of the conventional current, so minus E1. Minus IR3, minus IR4, and we go back we reach the point A, so that's equal to 0. Now, we're going to get the EMFs on the left-hand side, move everything else over to the right-hand side so we can get rid of all those, or most of those negatives. So we have E2 minus E1 is equal to IR1 plus IR2 plus IR3 plus IR4. Now we'll factor out the I's. We'll have the resistors here. We'll divide everything through by the resistors, flip the equation around, and solve for I. So I'll just do that in one step. The current is going to be E2 minus E1 divided by R1 plus R2 plus R3 plus R4. Okay, E2, now we can just plug in the values because we know everything except for the current. E2 is 18, E1 is 6. So 18 minus 6 is up top. And the resistor values are 4, 10, 4, and 6. So that's going to be 12 divided by 24, which is 0.5, so 0.5 amps is the current. All right, so we've solved for the current using the loop rule, and that's half of an amp. Now, we're going to continue on and solve the loop rule for this circuit in the same video. I need the space, so I'm going to erase this part. Okay. Now, looking at this circuit, we're going to start at point A. Looking at the EMFs, current is flowing this way, and that's 12 volts. Current is flowing this way, and we don't know the voltage on that. So, if this current is going this way and that current's going that way, they're going to meet at this point and come down. Since this is E1, I'm going to call this I1. Since this is E2, I'll call this I2. And they're going to meet here, so I will call this I3. And that actually gives us our first equation. I1 plus I2 equals I3. Alright, now we started at this point. We're going to analyze the left-hand side of this, and then we're going to analyze the right-hand side of this. Left-hand side, starting here, going over, we get plus E1. Going around, minus I1R1. Now you have to be careful because In this problem, you had one overall current, we called it I. It wasn't I1 or I2. In this one, you've got three currents, I1, I2, and I3. So you have to label that current, it's I1. You come to this point, and then you go down. So this is going to be minus I3R2. And, I3 is also given. I3 is equal to 3 amps. That was a given that I erased from earlier. Didn't write it back up. And going around, that's equal to 0. Now we analyze the right-hand side, starting here, going up. That's going to be E2 minus I2R3. Coming down, minus I3R2 equals 0. All right, we have three equations. And we are looking for, we don't have I1, so I1 equals question mark. We don't have I2, and we don't have E2. We have everything else. We have E1, R1, R2, R3, and we're looking for those other three missing values. So I'm going to start here. Okay, I1 we don't have, I2 we don't have, so we can't solve for that, but we know that I3 is given us 3 amps. So we can't start with the first equation. Second equation, E1 we have, I1 we don't have, R1 we do have, I3 we have, R2 we have, so we can solve for E1. E1 is going to be equal to I1 R1 plus I3 R2. Okay, we're solving for I1, so let me actually move this to the other side and divide by R1. So I1 is going to be equal to E1 minus I3 R2 divided by R1. Okay, E1 is 12 minus I3 is 3. R2 is 2. And R1 is 6. So 12 minus 6 divided by 6, that's 6 divided by 6, that's 1 amp. And so now we know that I1 is equal to 1 amp. Now, if we know I3 given, and we know I1, we solve for that, we can figure out I2 from this equation. I2 is going to be equal to I3 minus I1. So I2 is equal to 3 minus 1, which is 2 amps. So I'll just write 2 amps here. And now we're just solving for E2. E2 is in the third equation. If we add these to the other side, we can solve for E2. So I need this space, so I'm going to erase this. E2 is equal to I2R3 plus I3R2. E2 is equal to I2. I2 is 2. R3 is 1. I3 is 3. And R2 is 2. So that's 2 plus 6, which is 8 volts. And that gets us all of our values. All right, and that's how to use the loop rules.